class with recording it. Okay, so problem 1, we want to compare the result from intensive and paced. And we have the data up here. Let's see what's the claim. The claim is to determine whether intensive tutoring is more effective than paced tutoring. So, intensive tutoring is more effective than paced tutoring. Now, when we say more effective, it means it should result in better grade. Okay? Hypothesis. Yeah, the reason we do tutoring is not to make students happy. I mean, yeah, I understand. You know, just like when we run class, the purpose should not be to make students happy. Okay, the purpose should be on the result, which result give us better outcome. Okay, so the more effective means that's alternate hypothesis. Okay, and then we would like to have the mean from the first group to be higher than the mean from the second group. Okay, then the complementary statement will be less than equals to. And then we will move this. We need to get a constant, so let me move mu2 to the left hand side. This will be positive. And mu1 minus mu2 less than equals to 0. Now our claim is here. And it is a right tail. Okay, step 3. So a lot more space. Step 3, test statistic. Test statistic. We don't have the population standard deviations from each sample, so I will use T. That is x1 bar minus x2 bar minus difference 0 over square root of sample variance from the first group over sample size from the first group plus the sample variance from the second group over sample size of the second group. Just get the result right away. Okay, then I use my calculator. I get 46.31 minus 42.79 close parentheses divided by the square root of 6.44 squared over 12 plus 7.52 squared over 10. I get 1.16615. And then step 4, the p-value. It's a right tail with degree of freedom 11 and 9. Then I will use 9. Okay, so this is 1.16615. The p-value will be here. So p-value is TCDF 1.16615. Degree of freedom will be the smaller or of each one, of either one. TCDF, oops, I'm sorry. I omit one thing, E99. 1.16615, comma, E99, freedom 9, and get, oops, that's not big, huh? Oh, that's not small. It's a 0.13676. Then failed to reject null hypothesis. So, informal conclusion. Failed to reject null hypothesis. And then step 6, conclusion. No space here. At 5% significance level, there is insufficient evidence to support the claim that intensive tutoring is more effective than is tutoring. So if we come up with this conclusion, will we do paced tutoring or intensive tutoring? If nothing else being considered, then I will do intensive tutoring because that's a less amount of time, right? You fix the time, okay? Yeah, we're covering pace tutoring cover less material in the same amount of time. Intensive tutoring, therefore, cover more. Okay, and the result, if there's no difference, why do we want to spend more time? Right? Okay, but of course, for business point of view, then suppose you have an SAT prep, right? SAT preparation, then which will be better? Then I will open two. Type of classes. One intensive, that's usually done in the summer, okay, and the other one is PACE. By the way, our summer class here is also considered an intensive, even though our math department trying to make it not so intensive by making it 8 weeks. Okay, so it's not as intensive as it could be, but at East LA College, for example, their stats class is actually 5 weeks. You know, it's 5 weeks, Monday to Thursday only too. So they actually meet around 3 hours to 4 hours per week. I mean, per day. Okay. Now, if you ask me how about the result is actually better at WLAC College. But let me mention this. Let me mention this. 5 weeks, 8 weeks, 15 weeks. This is the best. This is the second best. This is the third best. That's from the result from my own classes only. So when we go into 8-week class, we tend to be better. Okay, and then compared to 5-week class, 15 weeks classes actually have a better passing rate. Okay, so I can say that 8 weeks is actually good pace. The speed is actually pretty good for most students, while 5 weeks is a bit too fast. Now, mind you that even in that 5-week class, we have a lot of repeating students. Okay, now 8-week class and 15-week class, 8-week class may be better, like better passing rate, maybe because of we have more repeating students. But at the same time, it turns out that those repeating students still not doing as good in 8-week class as they have experienced in 15 weeks. So you can make it faster and you can say that they're repeating, but they're not doing that well anyway. But when we compare those who actually took the class only first time took the class, the 8-week class is actually better. So if you take a look on my teaching history, you will see that in the summer I tend to teach statistics class at WLAC College. Only recently I start teaching statistics at regular semester at WLAC College, and that's also because the math department wants me to do so. Okay, number 13. Number 13. A nutritionist claims that the proportion of individuals who have at most an 8th grade education and consume more than the USDA recommended daily allowance of 300 milligrams of cholesterol. So the proportion of 8th grade, let's call that 8th grader, even though I believe this refers to adults with highest education, 8th grade or less, has higher proportion in consuming cholesterol compared to those who has at least college education. Now then, let's look at the data. So let's say the first one is the how to say that, less than high school level, and the other one is some college. And the sample size for the high school one is 320, and 114 actually consume too much cholesterol, daily cholesterol. And then for N2, those who has at least some college, 350, and 112 of them has too much cholesterol in one day. Now then, the question is P1 greater than P2? That's the claim, right? That's the claim. Yeah, that's the claim. Okay. It's higher, so this is the claim. Okay. Then step 1, the proportions of the claim. Claim the proportion. Wow, this is a long sentence, huh? Of individuals who have at most an 8th grade education consume more than USDA recommended daily allowance is higher than those, let me just rephrase it, those who have at least some college education. Or less. Okay, and then step 2, hypothesis. Alternate hypothesis P1 is greater than P2. P0 less than equals to P2. And the claim is here. Oh, you know what? Let me modify that first. So this will be null hypothesis equals to P1. I'm sorry, alternate hypothesis, not alternate. Is equals to P1 minus P2 greater than 0. The null hypothesis is the one P1 minus P2 less than 0. The claim will be here, and it's also right here. That's a right here. Again, the one that I write in red here is you don't need to write. Okay, you don't need to write it, but it will be nice if you do. Okay, and then test statistic. Let's prepare some number first. So how about P1 hat? P1 hat is 114 over 320. That's 0.35625. But P2 hat is 112 over 350. That's 0.32. It's only 3.6 something percent difference. Now the thing is that 3 point something percent difference big enough? Oh, I still need one more. I still need the pool proportion. That's 114 plus 112 of 320, 350. That is 2.6 over 650. No, 670. Zero point 33731. By the way, the pool proportion should be a number between P1 hat and P2 hat. Okay? Yeah. P should be between P1, P2. That's not a good word. Maybe I write it in words. P hat is between P1 and P2 all the time. Okay, all the time. Okay, let's start with the test statistic. it will be C equals to P1 is 0.35625 minus 0.2, that's P to that, minus the difference of proportion in null hypothesis is 0 over square root of P bar 0.33731. Let me see, I have that. Okay. Times 0.66269 over 300, what in 320, okay, plus 0.3371731 times 0.66269 over 350. By the way, if you want to save your time in typing this, of course, you need to know some algebra to know why this is true. You can actually do the following. This is 5625 minus 0.32 minus 0. So some instructors actually use this formula. They use this formula. They use 0.33721 times 0.66269 times 320 to the negative 1 plus 350 to the negative 1. Yeah, if you know some algebra, you know that you have common factor these, right? You factor it out, right? You factor it out, so it becomes P bar Q bar, and then 1 over N1 plus 1 over N2, which we can represent as P bar Q bar N1 to the negative 1 plus N2 to the negative 1. That's for the denominator. Okay, if you don't want to type too much, right? If you don't want to type too much. Anyway, let me use my calculator to compute that. The thing is, like, when you type this many numbers, be aware that once you miss one digit, the result can be very different. You see that even when I try to copy that down, I make mistakes, right? So that's why be very, very careful when you plug those numbers in. How did I get 33731? The P bar. Is it my P bar? Yeah, that's my P bar. Is it okay? Yeah, that's my P bar. And then I get, this is 0.99131. Oh, it's actually, I know right away, anything that less than 1.5, like if the C score is less than 1.5, then that's a fail to reject null hypothesis. But of course, that's by instinct, right? Okay, because I do too many stats problem. Now let's see the p-value. Now, of course, it also depends on the significance level though. But the significance level that we use, the smallest is 90%, sometimes 88%. What am I saying? Sometimes significance level, 10%, very rare 88%, but we hardly see anything less than 12% significance level, 0.9911. So the p-value will be normal CDF 0.99131 E 901.
Good morning, Papa.
Good morning.
Your,
This is
you are
0.16077. So then, step 5, informal conclusion. Fail to reject null hypothesis. What is the alpha, by the way? They don't tell us. So we use 5%, right? And then conclusion. At 5% significance level, there is insufficient evidence to support the claim. Then let me copy paste. Okay, so from here we see that at least with these two groups, we found out that your education level doesn't really tell you if doesn't really affect, maybe I should say, not significantly affecting your diet in cholesterol. Okay, now of course, this data here very likely is not a real data, not empirical data. It's just hypothetical data. Okay, but it doesn't matter about the outcome though. It's about how we process the hypothesis testing. Okay, now let's go on to what I really want to cover today. What I really want to cover today is hypothesis testing on two population proportion, but I'm sorry, two population mean, but it is in, oh, check, just to confirm. Yeah, because the p-value is greater than 5%, that's right. Yeah, the p-value is greater than 5%. Okay, so this is, I think this is 12 point, is it 12 point or 11 point? Hypothesis testing into population mean dependent case. Is it chapter 11? I somehow think it's chapter 11. Check. Yeah, inference on two samples. Okay, yeah. So what we do here is 11.2. This is 11.2. That's hypothesis test. I focus on the hypothesis testing. Hypothesis testing on full population means. But this time we deal with dependent case. Dependent case. Now, we do this hypothesis testing if we want to see if the treatment is effective or not. Okay, is used or performed on the same sample before and after some treatment. Okay, for example, we will apply this for example, we apply this for the following, that we have a group of students. We want to see if is a particular SAT prep is an SAT prep helpful in improving SAT score. And the way it is being done is you will select a sample, a sample. Okay, let's say a sample of, let's say, 3 or 4 people, or maybe even more, of course. And then we want to assess these students before assessment. Do I pronounce it right? Double S. Is it right? I don't know. So assessment before the SAT prep and the one after they have SAT prep. And then let's say the first person start with 500s after the SAT prep, that person gets 600. And the second person start with 650 and after SAT prep is 680. And the third person, let's say 430 and end up with 580. And the last person 750, end up with 720. Let's say we have something like this. Okay, now then the question you want to answer, so is it helpful? Okay, now the reason we call that dependent case, because we actually have 2 samples. Okay, we actually have 2 groups of data from the same sample. This is the one before that those students take the SAT prep, and this is the one after the SAT prep. So pre-treatment and post-treatment. Okay, now notice that we don't have the average from all students. We just have some people, but we were able to find their assessment scores before the prep and after the prep. Now, so what happened then? We can couple it. Okay, from the first sample, from the first element, we have the before and after scores, and likewise for the second one. Now that's, and the third one, and so on and so forth. Now that's why this dependent case is more well known, is better known as match pair case. Match pair case. Because you can pair them. Okay, now the way we will attack this kind of problem is by not looking at, so we want to actually do this. What we want to do is we want to see if mu2 is greater than mu1, right? Okay, and then that's our alternate hypothesis. Okay, and then we modified that, becomes mu1 minus mu2 less than 0. Right? That's what we did when they were independent case, the one we learned on last Wednesday, the one we had in our first question earlier, the one we did earlier. But notice that for this case, we can go even further. For this case, we can go even further. Instead of computing the difference of the means, we can compute the mean of the differences. We can compute the mean of the differences. Okay, so instead of finding the mean for each and subtract, what we will do is we find the difference. Okay, so let's call this x1 minus x2. I don't like, yeah, x1 minus x2 is good. So call that the difference. Okay, so this is negative 100, this is negative 30, negative 150, and this is positive 30. Okay, now later on we will be able, from this data, we'll be able to find the sample mean of the differences and the sample standard deviations of the differences. Okay, and you will see that we basically treat this as hypothesis testing on population mean population mean of differences. Okay, therefore we will use t-test. Okay, you will see that's actually what happened later on. You will see that's what actually happened later on. Now, in many cases, you will see that this hypothesis testing will give us better result if we want to see a treatment is good. Okay, so before that treatment, after that treatment, without treatment compared to after treatment. Okay, yeah. And how about the test statistic? You will see the test statistic. That will be t equals to d bar minus mu d over standard deviation of the differences over square root of the sample size. Now, I want you to compare to what we had before. That's x bar minus mu over s over square root of n. Okay, that's what we have in chapter 10. I think that's 10.2 or 10.3. Not sure. Okay, like what I said before, using the template I had, and again, that's the common procedure being used. You will see that only step 2 being modified a bit and only step 3 being modified. Okay, the rest actually the same. Okay, so instead of dealing with each case, what we do, I teach you the general pattern of hypothesis testing first. Okay, those 6 steps, and keep on using this template for future cases. Okay, now let's start with an example. Let me pick question from our book. I try not to use a big number, the one with a lot of samples. So let me pick question number 4 from our textbook. Question number 4 from our textbook. Okay, so we have this thing here. Okay. We will, this one here. Oh, yeah, that's part D. We can just do it also. Determine DIs, basically the difference from each pair of data. And they tell us to do xi minus yi. So our D's here, will be x1 minus y1, x2 minus y2, and so on and so forth. So the first one is negative 0.4. The second one is, what's that, 1.5? The third one is 1.0. Okay, the fourth one is negative 1.3. The fifth one is negative 1.7. Is it 1.7? No, it's not 1.7. That's 2.3. That's 2.3. Negative 2.3. I do it visually. That's why I may make mistake. And then this is negative 6.9 and positive 5.1, negative 5.3. Those are the D's. Now use these informations here to find D bar. Of course, then you need to find the sum. The N is easy. The N is 8. That one is something you know. How about the sum of D's and sum of D squared? So we are done with part A. Now for us to do part B, we need to answer this question first. Okay, now the sum of these is, then we use your calculator to add them. Negative 0.4 plus 1.5 plus 1 plus negative 1.3 plus negative 2.3 plus negative 6.9 plus 5.1 plus negative 5.3. What did I do wrong? I typed something wrong. Okay, I get negative 8.6. And then the sum of d squared, we are squaring them. We are squaring each one of these data. So actually, I don't need to worry about the negative sign. Just square them right away. Okay, 1.5 squared plus 1 squared plus 1.3 squared plus 2.3 squared plus 6.9 squared plus 5.1 squared plus 5.3 squared. I get 112.1. Now, of course, if you remember, we can use our calculator for this, right? Yeah, we can use our calculator for this. Let me wait. Let's use calculator instead. Let's see what's my list here. I have 1, 2, 3. Okay, let me clear them first. Let me clear the stats. Clear list. I want to clear list 1, comma. I want to clear list 2 also, comma. I want to clear list 3. Boom. So let's check. Edit. Boom. Okay, so it's clear already. Now I will put it in list 1. Okay. I will put it in this one. Okay. Notice that I did my D, the differences there, right? Okay, I did the differences there, which if you use your calculator, you don't need to. But of course, using calculator reduce your ability to actually, how to say, to actually know what happens in between. Okay, that's why I show you the original work first. But let's see. So this is, I plug in the data. The first list are these in. You have to put it in order though. Okay, because later on when you subtract, it's supposed to be in order also. Remember that's a match pair. 11.8. It's data number 6, data number 7. 1, data number 8, 18.6. That's for the first list. The second list, 19.8, and keep an eye on the matching in the first list. So 18.3 correspond to 16.8, and then 22.1 correspond to 21.1, and then 22.0, that's for 20.7, and then 21.5, 18.7, 15.0, simply 15, 23.9. Okay, so we have list 1 and list 2. Now, list 3, I will make it as the difference right now. When you move your cursor, you have your highlight here, move it up, boom. And then you will type list 1 minus list 2. So the number you see there is actually the number I have here. So the first data, negative 0.4, the second data, 1.5, 1, negative 1.3, negative 2.3, negative 6.1, 5.1, and I believe the last one is negative 5.3. Okay, now then, how do I get the sum of D and sum of D square? Remember, we did this before. Okay, go to calculate, one var stat, and then you do list 3. We just look at list 3. Okay, so you see that my sum of our calculator, think of that as axis, just the data, right? We know it's supposed to be differences, D. Okay, but we have the sum of X on our calculator, which is our sum of D. Sum of X squared on our calculator is our sum of D squared. Okay, so I can use these informations also to compute further what is my D bar and what is my SD. Okay, but for me, I need you to show me the computation though. Okay, my D bar will be negative 8.6 over 8, which, if you look at your calculator, so at least you can pretend that you do it by hand, right? Okay, negative 1.08, 0.75, my bad, 0.75. And then this guy here is 8 times 112.1 minus negative 8.6 squared over 8 times 7. And you use your calculator to compute that first, but let me save that first. From our calculator, we have 3.83322. So SD equals to 3.83322. That's our sample standard deviation of the differences. Okay, let's compute it. 8 times 112.1 minus negative 8.6. I ignore the negative because I'm going to square it anyway. Okay, and then divide it by 56. That's 14. That's 14.69357. 69357. Now then I apply the square root of that answer. 3.83322. And it is in line to what we had earlier, right? The one in red. Okay. So here's the thing though. The one I show you on paper here is the way you're supposed to show it to me in my test. Okay, the one I show you here And you can still use your calculator, but at least pretending that you actually do it manually. Okay, and then that's for part B. Let's see part C. Test if mu d not equals to 0 at alpha equals to 0.01. So we don't have the claim, huh? The claim is not given. No. It goes to step 2 right away. So later on, the furthest we can go is actually step 5. Remember the scheme. There's 1, 2, 3, 4, 5, 6. 6 responds to 1, right? Now, because we don't have step 1, then we won't be able to have step 6. Okay, they give us step 2, right? So the furthest we can go is actually step 5. Okay? Even if you have traditional method, okay, even if you have traditional method, these rules actually still apply. These rules still apply. If they don't give us the claim, then we will not have step 6. Okay, if they don't give us step 2, then we will not have step 5, we will not have step 6. Okay, let's come back here. Hypothesis. Now, they don't tell us if that's null hypothesis or alternate hypothesis, but we know it's alternate hypothesis because it doesn't have equal sign. Okay, so the null hypothesis will be mu d equals to 0, and the claim is here. Oh no, we don't have the claim, so I cannot say that. But we know that this is two-tailed. This is two-tailed. Then step 3 has statistic. That will be P equals to D bar negative 1.087. 0. Why I keep on using it? Negative 1.075 minus 0 over 3.8332 over square root of 8. I use my calculator. Negative 1.075 divided by 3.8883332. I get negative 0.79321. Okay, and then step 4, the p-value. That's a two-tail. Negative 0.79321. I need to find the area here, but then I double it. So the p-value is 2 times PCDF negative E99 negative 0.79321 degree freedom 7. So TCDF negative big number comma negative 0.79321 with degree freedom 7. I get 2 times 0.22685, but let me multiply it by 2 right away from my calculator. So I will get 0.45367, so 370. Okay, now the p-value is too big, right? More than 5%. So we will say informal conclusion. Informal conclusion, we will fail to reject null hypothesis. So I'm done with this one question here, but actually I want to show you something. We already have the data. In fact, we already have the differences, so on and so forth. Let me go back to my calculator. Okay, and I want to do hypothesis testing on this. So I will go to stat, test. Okay, now I will do t-test because we already have the differences, right? Where's the differences, Thomas? In list number 3. So I use data. Okay, the mu naught is 0. The list I use will be list 3. The frequency, as usual, is 1. The alternate hypothesis not equals to 0, and then we'll calculate. Let me put that here. Compare with what I have there. Yeah, compare with what I have there. You see my test statistic is the same. Right? And my p-value, let me go down further. My p-value is also the same. Right? So yes, what happened with other classes? Then the teacher will only teach them how to plug in calculators. Okay, and do this, punch this, punch that, you get this result. As long as the p-value is is less than the alpha, then we reject null hypothesis. So that's what they thought. Okay, but I want you to go further into what's the meaning of what we're doing here. Okay, that's one. I tried to teach you 2 things at once. I know it's quite difficult, but I hope you can follow me. What will happen with your test 4? I basically need you to do it manually. The way I show you here, the way I write here, okay? But you can use calculator to confirm, right? Yeah, you can use calculator to confirm. Now, the other thing is about your final. Your final has some multiple choice, but there will be hypothesis testing part in which you will show work almost manually, but a lot of teachers allow you to use calculator to show the computation. So instead, for example, for the test statistic, okay, when it comes to final, you don't need to show this thing. For test statistic, you just quote right away from here. They still want you to do the template though. Okay, they still want you to do the template in your final, but you don't need to show your computation anymore. Okay, like the p-value, you don't need to do this computation, you just show from the calculator. But that's for your final. Okay, for my test 4, I still need to I still need you to do I still need you to show that manually, and of course use your calculator to confirm. Okay, do the template as usual. Okay, but can quote result from calculator. Now, what I don't know until now is, are we required to use department final in our final? Okay, or can I use my own final? Now, I myself don't want to think too hard, so writing a final is actually a trouble for me. So I will just use the final from the math department. Okay, I will just use the final from the math department. Okay, did you make list 3 without calculating first? Actually, when I did my list 3, where's that? When I did my list 3, I'm still at the mode of sharing screen, right? Okay. When I did my list 3, I did the subtraction. So what I did here is I subtract L1 minus L2. Now, if you have error, very likely because the numbers you have, the number of data you have on the first list and the number of data you have in your second list are not the same. It could be the case. Okay, it could be the case. Now, please check your calculator though. Don't worry, don't worry. What happened to you is actually something that we all need to be aware of. So let's learn from the mistake. Are you checking that, by the way, Bob? They're equal in length, but you still get error. So your L3 gets error, you mean? Oh, no, 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 no. You type L1 minus L2 into your L3. So here's the thing. So let me clear list first. Give me a second. So let me clear list. Let me clear list 3 first. So this is what we have, right? Now then, when you move your cursor to the right, you are in L31, the first entry of the list number 3. Okay, now that's not where you put it. You go upstairs, okay? You go up there. Do you see that now? And then you do L1 minus L2. L1 minus L2. Then it will fill it up for you. Okay, good, 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 good. Yeah. Well, what I show you here is actually quite crucial though. What I show you here is actually quite crucial. So I want to say that even if I just teach you how to use calculator without without the interpretation, what happens in between, we still have students actually fail the class. And the reason they fail the class because they forget what they mean. They forget how to punch in calculator. Okay, yeah, they forget how to punch in calculator. Well, anyway, so we're done with this part C, question part C. Let me go on to part D. Part D, compute 99% confidence interval about population difference mean. Okay, so in part D, what we do is actually the 3 steps. Okay, step 1, best point estimate will be the D bar, which is negative 1.075. Critical value, that's T critical. Okay, T critical, that's it's 99%, huh? Let me write it down. It's 99% confidence level. So that will be inverse T 0.995, degree of freedom 7. Inverse T, oh, I don't have it. Oh, here's my calculator. Inverse T, point 995, that's the area to the left, degree of freedom 4 or 7. Hey, what am I doing? I need to get up from okay. Okay. Inverse T 3.49948. 3.4994. And in step 2, margin of error will be the T critical. Standard deviation of the differences is what? 3.83322. 3.83322 over square root of T. That will be 4.7, 4.74266. So part 3, 99% confidence interval for mu D will be negative 1.075 minus margin of error negative 1.075 plus margin of error. Okay, negative 5.81766 less than mu D less than 3.66766. So the confidence interval method, the confidence interval question is still something you can answer just like before. Now, the thing is, can we use calculator for that? That's always a good question, right? Can we use calculator for that? Yes, the answer is yes. You go to stat, test, but this time you do t interval. You do t interval, okay? The data will be list 3, and then the confidence level 0.99. Boom. But I hope you remember why I want you to do it in 5 decimal places. I hope you remember that, because some people just use calculator, right? Okay, so differentiate. When I ask you to do it in my test, I need you to do it manually, and you can use calculator to confirm. But you see the difference. The calculator will give you 3 decimal places for this, and only 4 decimal places for this. Okay, you see what I mean? And yes, in your test 3, I have students doing confidence interval with a lack of all those numbers. You know, basically, these people get this result, and I say no, this is not the way you do your my tests, and only one person kind of like try to get into the argument with me. But Thomas, and that student actually say this to me, Thomas, I don't have time to actually deal with you. Okay, fine. What makes you think I have time? The reason I talk to you that way, because I want you to change. Otherwise, I keep on penalizing you for something unnecessary, right? But anyway, if that person don't want to listen, fine. I'm fine with that. I'm here to teach, but if you don't want to learn, that's fine too. Okay, but the way I grade is basically the way I teach you. Okay, I grade you based on my teaching, not based on what other people teach, not based on the final answer only, but based on how I teach you. So I want to see procedure. I say that from the very, very beginning, at the beginning of this class. Okay. Well, anyway, that's only one question, Thomas, and it takes you half an hour. No, not really, because I actually teach you a lot of things at once. I teach you how to use calculator, how to plug in data, okay, and then what relates to what. For example, here we don't have the claim, therefore we don't have step 6, right? Okay. In the next 40 minutes, we will do problems with. Let me pick question from the book again. Let's say this one. I picked number 8, so it's word problems. We go all the way on here. Maybe here. So I will teach you at the same time problems that may show up in the department final. Okay. Why are these match pairs data? Why are these match pair data? Go back to the key is because the same person is asked to do two things, to go to blue screen and to do seeing red screen. Okay, it's the same person. So one person have two different treatments. Okay, each sample element gives two results. I think I should say give one result for each treatment. One result for each of two treatments. Okay, second, in this study, the color that the participant was first asked to react to was randomly selected. Why is this a good idea in this experiment? The color that the participant first asked to react to was randomly selected. I think they were asked to do blue screen first and then red screen. Why is this a good idea in this experiment? I don't know. That's not what they say. But yes, I agree that they're supposed to randomize because we want this experiment. From what I read here, they get the blue screen first. Oh, I see. Okay. So basically to reduce or to avoid, to be more precise, to avoid the effect of having a particular color first affecting the reaction. The reactions for each color. So let's say you get blue first. And then because you have blue first, then your reaction for the second one change. The third one, is the reaction time to blue stimulus different from reaction time to the red stimulus? Okay, then I need to do hypothesis testing. That's the claim. Okay. Reaction time to the blue stimulus is different from to the red stimulus. Step 2, hypothesis. So the null hypothesis, alternate hypothesis. We want to see that the reaction time. So let me use T. Now I don't want to confuse this T with my other T. So let me use mu then. Mu for blue is different from mu for red. That's the original one, right? Okay. But then we modified that will be mu for blue minus mu for red, not equals to 0. But because this is a match pair, we will go further. We will call that the mu of the difference. Okay, and then from there we see that that's a two-tailed test. Okay, so this is a two-tailed test, and the claim is also here. Let's do step 3. Step 3. I will just use calculator right away to get the data. Okay, to get the data. So this is 3. Step 3. Let me clear the list first. So I want to clear list 1, list 2, list 3. Clear list 1, list 2, list 3. Okay, and then edit list 1. Good thing it's only 6 out. 0.582, 0.481. I would like you to do to write all of them. Yeah, I would like you to write all of them. Even though at times I get more lenient, right? Let's say here there are actually 3 parts, right? This is the first part, the second part, the third part, and you write only the first and the third. I usually fine with that. You know, I usually fine with that. Let me say that I'm fine with that. You need to write the first one first, and then the third one. Even though I would prefer you to write the first, the second, and third also. Okay, and then 0.841, 0.267, 0.685, 0.45. Let's go to list 2. 0.408, 0.407, 0.542, 0.402, 0.456, 0.582. Then I go to L3. I do L1 minus L2. It will compute that for you. Okay. Now then, the thing is in my test, I need you to plug those numbers in though. So I need you to write, for example, this is when you use red color, this is 0.174, 0.074, and so on and so forth. I want you to plug that in. Okay, but what you after that, then you do, okay, the sum of d equals to what, sum of d squared equals to what, and then d bar equals to d whatever the sum of d divided by 6, right, which we can actually see from here. You can see from there. This is 0.558, right? And then 0.20871. 0.20271. Now the sum of d will be 0.558 over 6. That's that. So the d bar will be 0.093. And then variance of the differences will be 6 times 0.20271 minus 0.558 squared over 6 times 5. Let me use my other calculator, the one I have a pen right now. I get this is 0.03016, and then the square root of that number is 0.17368. Let me compare with my calculator. I get slight difference here. I get slight difference here. I get slight difference. But I think it has something to do with the fact that I actually do rounding here. Yeah, I did rounding there. Rounding. Let's see. 0. Okay, so let me use the result. Let me put the result here. But then your step 3, let's do the step 3 here. Test statistic. T equals to, what's my mean again? 0.55 A minus 0, right? That's the one we get from the null hypothesis. Okay, over 0.17368 over square root of 6. B such a big one. Okay, 7.86973. Get the message coming. Let me see. D bar or sum of D. D bar here. Sorry. So it's not. Thank you. So this is not correct. No wonder my number is so big here. This is so looks so wrong. This looks so wrong. Thank you. That's 0.093. 0.093. Do the correction. Yeah, it looks better. 1.3116. Okay, and then my step 4, p-value. It's two-tail, huh? Is it two-tail test? It's a two-tail test. It's 1.31162. And I need this guy times 2. So the p-value is 2 times TCDL 1.31162 E99, degree freedom is 5. 2 times TCDL 1.31162. So I get 0.24664. So step 5, informal conclusion. Fail to reject null hypothesis again. And then step 6, the conclusion. I didn't even look at the alpha there, but what's the alpha they want? 1%. So okay. At 0.01 significance level, there is insufficient evidence to support the claim. Copy paste. Okay, now calculate. Suppose I do hypothesis testing using calculator. Go back. Suppose I do hypothesis testing using calculator. So there will be t-test, right? Okay, using data from L3, and we do it oppose at equal not equals to 0. Anchor, I get this. Now, you see that my t is a bit off. I wonder why my t is off. Oh, I think it has something to do with my SD. Did I compute it right there? Ah, I see what happened. I see what happened. So you see that because I round to only 5 decimal places, right? Because I rounded to 5 decimal places, then the number I use here is different from our calculator, and our calculator actually get the standard deviation is a bit off. They have 7. Okay, so if you do it by hand, you are a bit off, and that difference result in a slight difference in the p-value. Slight difference in p-value, and the slight difference in t statistic, the test statistic. Okay, but good thing is that slight difference is not changing our conclusion. So Thomas, which one do we follow in your test? In my test score, follow your hand computation. Okay, follow your hand computation. Follow the one you round to 5 decimal places. Okay. Because if you say, oh, Thomas, I use calculator and I get different result, well, then you basically tell me that you follow calculator instead of doing it manually, right? Okay, now I have 5 minutes left. I would like to go on further in question number D, and if possible, question E. Construct 99% confidence interval about population mean difference. So part D, step 1, best point estimate will be D bar equals to 0.093. That's what I remember. And critical value, T critical equals to inverse T. What is the significance level? 99%. Okay, so this will be 0.995 degree of freedom 5. be 4.03 to something 14. Step 2, margin of error 4.03 to 14 times sample standard deviation of the differences 17368. 0.17368 over square root of 6. Now, remember, don't use calculator because we already use different numbers. I mean, don't use the result from calculator to do this because we start with slightly different numbers by rounding. I get the margin of error is 0.28590. Then step 3, 99% confidence interval for mu d will be 0.093 minus 0.28590. That's d less than 0.093 plus 0.28590. I get negative 0.19290 here. This is oh, I think I made a mistake somewhere. Since 0.3789. I somehow think I made a mistake somewhere earlier. Is this correct? Oh, okay, good. I confirmed that using the calculator. So now then, go back to calculator. Suppose I want to do hypothesis testing. So test, go to stats, test, but I use t interval. Okay. Data list 3. Okay, calculate. Okay, so it goes to some other numbers here. So see, if somebody give me this result in your test 3, I know you use calculator. Okay, so the students that I say that no, that's not how you do it using my way is like, hey, you know what? I know you just use calculator. Well, what I want is actually you do it the way I show you in class. Okay, the way I show you in class. Now, well, anyway, this is for part B. In the last 1 minute, I want to show you one thing. We want to do the scatter plot. Is it what they asked? Yeah, the drop box plot. The box plot of the difference data. The box plot, well, that's not really. Let me go to calculator. Now, what I want to show you is the graph, the scatter plot. I call that. Let me go to mode. then I want to do, what is that again? I forgot how to get there. Oh, stats, okay. Calculate. What's that again? The box plot. I need to find it out. I totally forgot what's the function to find those numbers. I do, this is L1, and this is L2. No, that's not right. I will find out this tomorrow. I totally forgot how to actually do the box plot using calculator. My bad. Yeah. Okay. Well, anyway, but that's what we need tomorrow. Your suggested homework from here will be, I would like you to do number 3, and then number 7, number 9. The suggested homework from 11.2, number 3, number 7, number 9. Now, what we will do tomorrow, is, that's why if you see the announcement board, not the announcement board, my bad, discussion board, I would like you to watch the lecture videos from YouTube, okay, to give us some feeling about regression, linear regression, and correlation. So we will do, that's actually the mixture between chapter 4 and chapter 12, as I remember. But maybe that's 13, I don't remember precisely. Yeah, basically we'll do linear regression. Okay, now the lecture video teaches a lot of details there, and I actually prefer to teach that method. Okay, but with the time I have, I prefer to just teach you how to use calculator and let the lecture video doing the interpretation, what this means, what that means. Okay, so tomorrow I plan to go straight to textbook problems. Okay, which also the question I usually ask in the test. Okay, that's then for today. See, I have a chat, sorry. Thank you.